Continuing section 8.4, we have of the function f of x equals 3/2 x minus 1. The first question says, is the point -2, -4 on the graph? Well, to check that, I'm going to substitute -2 for the x value. And I'm going to see if my answer is -4. So 3/2 times -2/1, that's -3 minus 1, which equals -4. So my answer is yes. Then it says if x equals 4, what is f of x? What point is on the graph of the function? If x equals 4, then I am putting in +4 in place of the x. 3/2 times 4/1, that's 6, which is 5, so f of x equals 5, and then the point on the graph of the function is 4, 5. If f of x equals 8, what is the value of x? So notice the different wording between parts B and C. Part B, we're told x equals 4. Part C, f of x equals 8. Since f of x equals 8, I'm going to have 8 equals 3/2 x minus 1, and I have to solve that equation for x. I'm going to add 1, and then I'm going to multiply by 2/3, that's the reciprocal, and I get 6. What point is on the graph of the function is 6, 8. What x equals always goes first. What f of x equals goes second. In our next example, determine whether 4 is a 0 of f of x equals -3x plus 12. Well, if something is a 0, basically what we're trying to find is when I put that number in for x, does it equal 0? So let's work it out and find out the answer. F of 4 equals -3 times 4 plus 12. That's -12 plus 12, which does equal 0, so my answer is yes. Determine whether -2 is a 0 of g of x equals -x squared plus 2x. So I'm going to put in -2 and see if my answer is 0. -4 minus 4, that's -8, which is not 0. So no, it's not a 0. Find the zeros of the function g whose graph is shown. So I have a whole bunch of points marked here. Some of them are kind of faded, you can't see them very good, but the important ones you can see. If something is a 0, what we are looking for are the x-intercepts, right there, right there. Except in this case, we're going to call them zeros. So multiple names for the same thing. X-intercept is the same thing as zeros. All right, example 6. Bob and Janet went hiking in the Great Smoky Mountains, starting at a height of 2,500 feet. They took 10 minutes to walk up a 100-foot hill. They walked on level ground for 20 minutes, then hiked down a 50-foot slope for 5 minutes. After 5 minutes of walking on level ground, they descended for 5 minutes down another hill until they were back at their starting elevation. Draw a graph of their elevation as a function of time. Alright, so my y-axis is going to be my height, and I'm going to put this little zigzag thing in there to indicate that I am skipping. I'm not going to count from 0 all the way up to 2,500, so I'm just going to put that indicates I'm skipping some values, and we're going to start with 2,400, 25, 26. My x-axis is going to be my time, and it looks like we're in minutes. And this will start at 0, and then we'll count by 5s. And we say they started at a height of 2,500. They took 10 minutes to walk up 100 feet higher. They walked on level ground for the next 20 minutes. Then hiked down a 50-foot slope for 5 minutes. After 5 minutes of walking on level ground, they descended for 5 minutes down another hill until they were back at their initial height. Example 7. A college student is heating a jar of spaghetti sauce. So in example 7, we're going to be measuring temperature versus time. The jar's already been opened. He takes it out of the refrigerator, dumps it into a bowl, and microwaves it for 60 seconds. After taking it out of the microwave, he lets it cool for 30 seconds before putting it on his pasta and eating it. Draw a graph that represents the temperature of the sauce as a function of time. Well, here we don't actually have any specific temperatures. All we know is that it was in the refrigerator, we heated it up in the microwave, and then it cools back down. So I'm just going to kind of pick an arbitrary temperature to start. I'm not even going to label a value. We heat it up for 60 seconds. So over the course of 60 seconds, the temperature is rising. So I'm just going to pick a higher point. Okay, so 60 seconds later, now my temperature is higher. And then it's going to cool for 30 seconds, but we know it's not going to get back down to the temperature it was to start with. It's only going to cool a little bit, so we'll just lower it slightly for the remaining 30 seconds.